Hello and welcome to your second Java project called Swingy. Today we are going to see how to build visual programs in Java using the Swing library from the Java Standard Edition. And we are also going to see how to build large projects using the Maven build tool. Well, the problem that arises in Java is when you want to try multiple external libraries. The classic way to use it is to download archives of your libraries that you want to use in the project and put them on the project class path. This is fine for small projects where you have few dependencies on other libraries, but when you want to use more dependencies and more libraries, this is going to get really hard for you to manage. Also because there are multiple versions for libraries, and then you can get into something that is usually called the Java jar hell. Why is it called like this? Because in Java you can export your project as an archive that has the extension .jar coming from Java archive. What this contains is the .class files of your project bundled together in a single file. The Java virtual machine knows how to extract the class files from the jar libraries and include them in your class path and use it inside your project. But as I said, doing this with a lot of libraries that have multiple versions can get really hard. And this is why we are going to learn today how to use the Maven build tool that will manage all these dependencies. How this tool works is quite easy. You have inside your project a descriptor file. It's actually an XML file which has the name pom.xml. This is the way that it should be named. And inside this descriptor file, you put all your dependencies that you use inside the project, the version of these libraries. And when you run the Maven build tool, it will automatically connect to the internet, search for the libraries inside the central Maven repository or another repository that you can configure inside your settings, and download those files into your project and automatically include them into your class path. We are going to see how to do this. First, if you want to use the Maven build tool inside your command line, you need to go online. On the Maven homepage, it's a project from the Apache Foundation, and you need to download it and put it into your path of your console. You can check that you have it installed on your computer by running the command. And you can see that I have it installed. I have the 3.3.9 version. Actually, if you use any version that's from the Maven 3 project, it will be just fine. You can see inside my folder that I have a file called pom.xml, and this is the descriptor file of my project. We are going to see how this file looks. Here you defined the group ID of your project, the artifact ID, which actually is the name of the project, and the version of your project. Every time you make a new release of your project, you can change this version here, increment it, and it will build it with this new version. Below we can see we have the dependencies tag, where we describe the list of dependencies of our project. I have here 5 dependencies which are not part of the Java Standard Edition. You can see I have here the JavaX validation library. I have a library that is really cool called Lombok. This actually is really nice because it helps you to get rid of a lot of boilerplate code and replace the getter and setter and toString methods with just a few lines of code which are actually annotations that will make your code a lot more clearer. Here we have the Hibernate validator, which actually is an implementation of the JavaX validation API. This library will help you validate your model classes so that you can be sure that the data that you have set inside your model classes is correct. we have the SL4J API and the SL4J simple implementation. This actually is a logging framework that helps you produce nice and beautiful logs for your application. You can also define multiple plugins for your build process. For example, the way that you want your project to be built. If you have any prerequisites before the build is done, you can do it here. For example, copy some dependencies, specify the type of packaging that you want for your project. For example, for this project, we're going to build it as a jar file. And of course, the Maven compiler plugin, which is mandatory to use because you want also to compile and build your project using Maven. If you want to see how we run it from the command line, you need to be inside the folder that contains the pom.xml file, and we just need to give it an instruction, Maven. I'm going to make a clean to be sure that my old classes are deleted, and also a package command that will compile and build my project. Let's see how it runs. Okay, and I have a successful build. At the end of the build, you can see that you have a folder inside your project that is called target. This is the default project. This is the default folder of your project where the compiled files are copied. You have here a classes file where all the compiled files reside, and you can see that we have our snapshot 1.0 version of our project already built. This is the way that you will work from now on with large Java projects, because Maven is highly supported in multiple environments. Also, IntelliJ has a plugin for Maven, so you can run Maven directly from your IDE. I will show you how you can do this. You can see here that you can have multiple run configurations. I have one that is called run for running the project and one that is called build. If I go and edit them, I have already prepared here my run configuration that is called build, and it will automatically run Maven with the clean and the package targets. Okay, this is how you're going to build your project. Now let's see what you will have to do in this project. Actually, this is a really nice game that you will have to build. It's a small text-based RPG where you will have a user interface built with the Java Swing library, and you will have multiple heroes that you can use inside your game, which are going to be loaded from a text file. The text file contains the description of each hero. So each line inside this file represents a hero that you can use inside your game. You see here, this is a comma-separated values format. So each string separated by a comma represents some specific attribute of the hero. You have the name, you have its class, you have the items that he has by default equipped on the hero. When the project will start, you will have to read this file and load the data inside your project. I will just show you a little bit the package structure of my project. I used a MVC, Model View Controller pattern for this. I have the view classes over here, which represent the views of my game. I have a util package. I have a storage package for accessing the data. I have a model package where you can see how the annotations that I presented to you before are working. You see here that I have the getter and the setter annotations that are put on the class, and Lombok will automatically generate at compile time my getter and setter methods for my data that I have inside here. You can see here this annotation, the not null annotation. This annotation is an indicator for the JavaX validation library to check that these values are not null when I ask it to validate the data. So this is really helpful because you don't need to do a lot of checks directly inside your code. You can use multiple types of annotations that are inside the JavaX package. We saw in the previous video how to use the documentation. So why not do it and see how to use it. I'm just going to search directly online because it's easier. JavaX validation, Javadoc. And we have here a sub-package that is called constraints. Actually, these are the annotations that you can use inside your classes. So you can see here you have quite some helper annotations that are really useful inside your project. You can see, you can check on a string if it contains digits. You can check on Boolean values if they are false or true. You can check minimum and maximum values, past or future for date fields, or specific patterns where you can use a regex on your string data. Okay, and let's go back to the package structure. You can see here I have a controller for the gameplay and one for the characters. If you will check a little bit the model view controller pattern, or maybe you know it already, you will see how these classes need to communicate with one another. Now, let's just see how the Swing library renders on my computer. Okay, you see it's not a beautiful user interface, but it's really fast to build. You can select your hero, and here you can see you have the data that is loaded from the heroes.txt file. And here we can see the stats of the hero. When you will select a hero, you will enter the gameplay mode. And as you will see in the project, you can have multiple directions where you can move. And you will have two buttons that you will use. You will use the fight button if you encounter a monster that you want to battle, or you can use the run and escape that battle. But if you run, you will not get any experience. Whenever you get experience, you will increase your total experience, and you will level up when you reach a specific benchmark. And of course, your stats will increase: your life, your health, your defense, and your attack. Now, let's get a little bit into the Swing library, because this is something new. Java used to be really used for building user interfaces. At the moment, everyone switched to web, I know, but still, when you use a desktop application, the Swing library is really helpful. We can see here, this is the class that models the start game window, and we see here that the secret relies in this statement because our class extends, so this means it will inherit from the JFrame class from the Swing package, and this will be really useful because we can use a lot of pre-coded functionality. We have here our startup method where our visual components are created. So you see here that we have already inside the library elements for the common visual elements, like a button, which is called a JButton, a layout manager, which will help us place the elements inside our window, and event listener for our buttons. You can see that we have here the JButton action perform method receives an event, which is the click event of the button, and we can tell it what to do when the button is pressed. We also implemented a window manager, which is an interface, and every class that implements it will need to give a concrete implementation of the methods contained inside the interface. Let's have a look at a more complex window. Here we can see in the startup method, in the init components, that we can have text fields, which is a JText field, labels, setting the color for specific components, combo boxes, and here we instruct the layout manager how to render the graphical elements inside the window. I will give you a nice hint. If you want to build your interface faster, there is an IDE from Oracle, which is called NetBeans, and there you can have a nice visual editor for your windows and where you can arrange your visual components by drag and drop, and it will ease yourself if you don't have designer skills like myself, and it will make your life easier and you will concentrate more on the logic of the game. This was it. Thank you for watching, and I wish you success in completing this project, and I hope you will enjoy playing it. Thank you.